Now we're going to go through some basics of understanding the chemistry of a saltwater pool. Around 95% of pools in Australia are saltwater chlorinated, so that's what we're going to focus on today. It is very important to understand your pool and your equipment because every system is slightly different. What we're going to talk about today realistically are the Australian standards or some general advice for water chemistry. So the most important, or you might say the most important two levels are chlorine and pH. That's how we know that the pool is safe to swim in. So from a sanitiser's perspective, we're going to be looking at our chlorine. The chlorine we would like to see between 2 and 4 parts per million. Anything higher than that, it may not be very fun to swim in. Anything lower than that, we can't guarantee that there's enough sanitiser to have killed all the bacteria in the water. You're going to be managing that with the saltwater chlorinator by adjusting both the runtime of the pump and the output of the chlorinator, which you would do seasonally to make sure that the output was proportional to the requirements for that season. You would also be regularly testing the pool water using appropriate test kit to make sure that you stay between those levels. pH is arguably the most important level. pH will essentially determine the activity of the chlorine. So typically we're looking for a pH between 7.2 and 7.6. As the pH gets higher than that, one, the water won't be very fun to swim in, but it also reduces the activity of the chlorine. So it's very important to keep the pH within those levels. As the pH gets lower than that, again, the water won't be fun to swim in, and it will increase the chlorine activity so much that typically the chlorine won't stay in the water. As you can see, what we're really striving for is balance. As the pH wants to go up, you will want to be then testing and dosing the required amount of acid into the pool to ensure the pH stays down. Pretty much the production of chlorine and exposure to the atmosphere is what's going to make the pH go up, and it may be able to go from a 7.2 or 7.4 up to a 7.8 within 7 to 14 days. So adding acid every week or two in summer might be important, to perhaps every 2 to 4 weeks in winter. The next level that we typically consider is called stabilizer. Now, when you come to a pool shop, we'll typically test the water for about 8 parameters. Only 2 of them will move quickly, that being the chlorine and the pH. So that's why we need you as a pool owner to test those regularly. When you're coming to a pool shop once a month, we will take care of the rest of them, but you may only be dosing those once or 2 to 3 times per year. The next chemical, as I mentioned, is called stabilizer. It's like a sunscreen. If we expose a pool to sunlight, within about 3 hours, the sun can remove 80% to all of the chlorine from the water. So once a year, we add this chemical called stabilizer, which will protect the chlorine from the sun. That stabilizer is not consumed at all, so once we put it into the pool, it should last for the full season. The next most obvious is salt. Every chlorinator will have a particular level of salt or minerals level that it wants to be at. The pool shop will test that for you, and based on the volume of your pool, will give you an indication of how many bags of salt you might need to add to keep you within the acceptable parameters for your chlorinator. Again, nothing will be using your salt, so the only way your salt level is going down would be if you were doing backwashing, perhaps too many bommies, or if you were to leave the hose running and water would then overflow from the pool. Typically, the major reason to lose salt in the pool is when it rains. The rain obviously sending salt out of the water out of the pool when it overflows. Throughout the season, your salt level should remain stable. If it doesn't, you may be looking perhaps for a leak in your pool. As we just spoke before about keeping the chlorine and the pH balanced, the next most obvious chemical is called buffer or sodium bicarbonate. Essentially, sodium bicarbonate is a level in the pool which will help keep your pH balanced or stable. As we add more acid to the pool, our alkalinity will get less, and then its effect on the pH will be less. The pH will then be allowed to move up and down. Another factor that will affect your alkalinity is rainwater. So during winter, it's important to check your alkalinity. And as we add more acid through the summer, it's important to keep your alkalinity within levels to ensure that your pH stays stable. One important chemical is called calcium. Calcium chloride is required in the water. In a concrete pool, for example, it's very important for the structural integrity of the pool shell. Fiberglass pool, somewhat less important, but forms a basis with the alkalinity of overall stability for your pool. Again, a pool surface and pool equipment will have required levels for calcium. We can get that from your builder and give you the required levels. It's very stable in the pool water. In Perth, we're very lucky that the tap water tends to hold the calcium quite stable. However, if with rain, it will be washed down the drain, so we will have to add some calcium to the pool. Last couple of levels, we will test for something called phosphates. Phosphates essentially is food for algae. If given the correct conditions, such as high pH or low chlorine, then an algae bloom can take over the pool and require lots of expensive chemicals and labor to clean that up. Phosphate remover will take those out of the water through filtering typically, and not allow the algae to take over the pool. It's more of a preventative maintenance tool. Finally is a level of copper. Copper in saltwater chlorinators isn't a requirement. It's typically a good safety net, which can ward off the green pool if some of the other levels go out, if you're not going to maintain the pool appropriately. There are other systems called ionizers, which will use copper as their primary sanitizer, but we can cover that on another video.